Okay, so earlier we have discussed about the theory behind permutations and combination. So today we will solve some examples related to permutation and combinations from previous JEE papers. Okay, so what is the basic difference between permutation and combination? Okay, so permutation is an arrangement. Okay, whereas combination is a selection. Okay, so what does permutation normally, what do you mean? We arrange n things taken r at a time. Okay. And without repetition, the formula for permutation is n factorial by n minus r factorial. Similarly, for the formula for combination is n factorial by r factorial into n minus r factorial. These are without repetition. But if you are repeating things, the formula will be n to the power r. And with repetition, the formula for combination will be n plus r minus 1 CR. Okay, just that you have to remember that. Okay, so to give you more clarity on what do you mean by repetition, suppose you are giving three numbers 1, 2, 3. Okay, so how you can make the arrangement? So remember, this is not selection, this is the arrangement. How will make the arrangement? So first place you can put 1, then 2, 3, then the other one, right? So with this there are two arrangements possible, with 1 at the beginning, with 2 at the beginning there is 2 arrangements possible, with 3 at the beginning there is another 2 arrangements possible. So total 6 arrangements are possible. So this 6 arrangement is nothing but your 3 factorial. Or you can write it as, like say, this is nothing but like NPR, which is equal to 3P3, right?
Yeah.
This is arrangement. So 3 factorial by 3 minus 3 factorial, so which is equal to 3 factorial by 0 factorial, which is equal to 1, right? So that is equal to 6. So this is a arrangement, that's why it's a permutation. So so when you take everything at a time, then it becomes just suppose n things taken n at a time, then it becomes n factorial only. Okay. So this is with permutation, I mean with repetition and without repetition, that you need to be careful. Okay. So let us try to solve some numerical. Okay. You have taken a picture of it? Okay. So the question is, find the number of positive integers less than 1000 having only odd digit. Okay. 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 So the question is, you have to find. The question is number of positive integer less than 1000 having only odd digit. Okay. So the question is number of positive integers number of positive integers, find the number of positive integers less than 1000 having only odd digit, less than 1000 having only odd digit. Okay, so we have digits like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, so what are the odd digits here? 1, 3, 5, 7, 9. Okay. So my odd digits are 1, 3, 5, 7, 9. Okay. Right. So with these I can have like say 1000. So less than 1000. Okay. So I'll have one digit number. I can have two digit numbers. Okay. I can have three digit number. Okay. So less than 1000 means I can have only this much. Okay. So if I have a four digit number, it will become more. Okay. So number of ways I can have one digit number. So how many number of ways? So number of ways I can have one digit number. Number of ways for one digit number. Number is equal to 5 only, right?
Yeah.
So why? Because I have five numbers and I am taking one at a time. Okay. So this is a permutation, right? This is a permutation. So it will become 5p1, right?
Yeah.
So 5 factorial by 5 minus 1 factorial, which is equal to 5 factorial by 4 factorial, which is equal to 5. Okay, so number of integers, one digit number is equal to 5. Okay. Similarly, number of two digit number. Okay. So number of two digit number. So this will be like in the first position, in 5 ways I can put. Okay, so let us say I have put 1, I have put 3, I have put 5, I have put 7, I have put 9. Okay, then the second one can be like say if I have put 1 here, this can be 3, this can be 5, this can be 7, this can be 9. Okay, so this is with 5. Okay. Similarly, with 3 also, I'll have 4 ways. So one, so like this, it will become
4 into 5.
4 into 5. No, here actually here repetition is also allowed, right? 1 also is fine.
No.
Yeah, your repetition is allowed. In the second place, you can put 1 also.
Okay.
So it will be like this. 1 also allowed, right?
Okay.
So this this becomes like 5 into 5, right?
25.
So it becomes like 5. So you are taking taking 2 from 5 with repetition, right?
Yeah.
So which is equal to 5 to the power 2.
Yeah.
Because your r is equal to 2 here.
Yeah.
Okay. So that's why the formula is n to the power r. Right. So when you are allowing repetition, so it will be n to the power r, which is n to the power r. So here n is equal to 5, r is equal to 2. So that's why it is 25.
Yeah.
Okay. Then your 3. So number of 3-digit number. So again it will be 5 to the power 3, which is 125. Okay. So your final answer will be
155.
125 plus 25 plus 5 is equal to 155. Okay. So now in this you have now understood the permutation. Okay. So you are making numbers. So arrangement is important here. not selection, right? And because you are repeating here, so it will be n to the power r.
Yeah.
Just remember, repetition means n to the power r is allowed. So this is your answer, 155.
Yeah.
Okay, so then you take a picture of this. Okay. Okay, so there are some there in permutation and combination there are two principles. One is called multiplication principle, one is called addition principle. Okay, so multiplication principle. So what does multiplication principle says? If an event occur in m different ways and a following event occurs in n different ways, then the two events uh, in succession can occur in m into n different ways. Okay, so if an event occur in m different ways and a subsequent event occur in n different ways, then the two events occur in succession in m into n different ways. We have been doing that actually. We will do some numerical, it will be more clear. And what is addition principle? This is multiplication principle. So there is one addition principle. What is this addition principle? If an event occur in n different ways, another in n different ways, then either of the two events occur in m plus n. So the catch is here, like the events occur in succession, but addition is either of the two, not in succession, either of the two. Okay, either of the two will occur in m plus n ways. That is addition. Okay, so one event occurs in m ways, another event occurs in n ways, then either of the two occur in m plus n ways. So this is very, very important. Okay, so there will be a lot of examples on this succession. Okay.
Yeah.
So we have done a lot of things. So we will do some numerical. It will be more clear. Okay. Okay. So let us try to do one numerical on permutation. Okay. Permutation. I take a picture. Oh. Okay. Okay, so let us do one on combination. Okay. So the question is like this. There are 15 players in a cricket team. Okay. So there are 15 players in a cricket team. Okay, there are 15 players in a cricket team, out of which 6 are bowlers, 7 are batsmen, 2 are wicket keepers. So you have 15, out of which uh, 6 are bowlers, 6 bowler, 7 batsmen, 7 batsmen, and 2 are wicket keepers. So 2 wicket keepers. So you have 6 bowlers, 7 batsmen, and 2 wicket keepers. So the question is, number of ways of 11 players be selected from them. uh, so you have to select. So you are selecting 11 players so as to include at least 4 bowlers, 5 batsmen, and 1 wicket keeper. So you have 15 players, out of which you are selecting 11 players with the condition that you have at least 4 bowlers. Okay. So what is the condition? You will have at least 4 bowlers. You will have at least 4 bowlers. At least 4 bowlers and 5 batsmen. 5 batsmen. And 1 wicket keeper. 1 wicket keeper. So this is the condition. So you should have minimum 4 bowlers minimum, 5 batsmen minimum, and 1 wicket keeper minimum. Okay. So normally in cricket team we cannot go with less than 4 bowlers. Okay. So sometimes they take more batsmen, less bowler. So that's why minimum 4 bowler, minimum 1 wicket keeper. You have to have 1 wicket keeper. Okay. And then you have to have 4 bowlers, 5 batsmen. And
If you add, it will be only 10.
no, this is
this is
minimum.
condition.
Anyway, you have to make it 11, but that is the minimum. Okay. So, so in how many ways you can do it? That is the question. Okay. So, so the total number of ways in which you have at least 4 bowler, 5 batsmen, and 1 wicket keeper. That's what you want to know. Okay. So, so when you have 4 bowler and 5 batsmen, then so you consider one case you have 4 bowler, 5 batsmen. Okay. In that case, you will have 2 wicket keeper. You have to have 2 wicket keeper. That is one way. Okay. Then there will be another way. You will have 4 bowler. Okay. You have so 4 bowler, 5 batsmen. Okay. Then another way, you will have 4 bowler, and then you can have 6 batsmen. Okay. 4 bowler, 6 batsmen means you will have only 1 wicket keeper. Okay. Then there will be another way where you will have 5 bowler also, because you have maximum 5. You can have 5 bowlers also. Okay. So when you have 5 bowler and wicket keeper, you have to have 1 at any cost.
Yeah.
Okay. Then 5 plus 1, this is 6. Then you will have 5 batsmen. So you have 5 batsmen, 5 bowler, and 1 wicket keeper. So that is also one way. Okay. So 4 bowler, 5 batsmen, 2 wicket keeper. 4 bowler, 6 batsmen, 1 wicket keeper. Then 5 bowler, 5 batsmen, 1 wicket keeper. Okay. So can you think a way where you will have say 6 bowler? So if you take 6 bowler and 1 wicket keeper, it will become 7. Okay. But you have to have minimum 5 batsmen. So that is cancelled out. Okay. So you cannot have 6 bowler, because if you are taking 6 bowler and 1 wicket keeper, it will become 6 plus 1 7, and only 4 batsmen. So that is ruled out. So 4 bowler, 5 bowler, this is acceptable. Okay. And then 6 batsmen, 5 batsmen, this is also acceptable. So these are the 3 combinations only possible. Okay. So when you are having this for this combination, so that multiplication principle will hold good. Okay. So this 4 bowler you are going to select from 6, right? So
Yeah.
this is a selection. This is not a arrangement. So combination you have to take.
Yeah.
So this 4 bowler you are taking from 6, which is equal to 6 C4. Okay. And then the next you have to multiply because they are occurring in succession,
Yeah.
not either. This is occurring in succession. So 5 batsmen you have to choose from how many batsmen? 7, right?
Yeah.
7 C5, right? Then 2 wicket keeper you are choosing from 2 C2. Okay. Then the next one is you are choosing 6 C4 into 7 C6 into then 2 C1, right? Then the next one is 6 C5 into 7 C5 into 2 C1. So the final answer is 6 C4, 664 into 7 C5 into 2 C2 plus 6 C4 into 7 C6 into 2 C1 plus 6 C5 into 7 C5 into 2 C. So if you find the addition of this, you will get the answer, and yeah, so the addition finally comes out to be 777. Okay, so this is a nice example of forming a cricket team, which is all about selection, not arrangement, and the multiplication principle you are applying here because they are occurring in succession. Okay, that's why multiplication principle.
Yeah.
Clear? So there can be questions like this. Okay, so the typical questions are related to this cricket team, football team, hockey team, or this playing cards and all.
Yeah.
So if you understand one thing, you can replicate the same principle in other. Okay. Okay. So we do one more numerical on permutation for better clarity. Okay. Okay. So okay, so this is interesting numerical related to permutation. So it is written if the letters of the word mother. Okay, so you have a word named mother. Okay, mother. Okay, so if the letters of the word mother be permuted and all words so formed with or without meaning, so does not matter whether it has meaning or not. So in dictionary normally everything has meaning. Here they have given the condition with or without meaning. Okay, be listed in a dictionary, listed as in a dictionary, then the position of the word mother is. Okay, so what will be the position of the word mother? Okay, so so uh, so you have letters like M, O, T, H, E, R. Okay. So like here this O, T, R, and these all will come after M. Okay. So don't worry about those. Only what is coming before M. Okay. So before M will before M E will come before M. Okay. And H will come before M. So E comes before M and H comes before M. So the word starting from E. So you want to see what is the position of the word mother. So before mother, what and all are coming, that we have to see.
Yeah.
Okay. So word starting from E, how many words can be formed? That is like say total words starting from E. Okay. Okay. So it will start from E. Okay. So E is fixed. Okay. So how many other digits are remaining? 336. 5 digits are remaining. So it will be E, and then you will have 5 different things, right? So so this will be like 1 into 5 factorial. So 1 E is fixed. The remaining things is coming in succession. So 1 into 5 factorial. That is word starting with E. Similarly, the word starting with H. Okay. So uh, yeah, so 6. Okay, so that is also 1 into 5 factorial. So these are the two words coming before mother, starting with E and H. Okay, this is 5 factorial into 5 factorial. Okay, then total words starting with ME. So now after E and H, you are the next letter is your M. So first you will are starting with M. So you will have something called ME. Okay. Before MO, okay, ME will come before MO. Okay. Similarly, MH also will come before MO. Because in dictionary that is how it is. Okay. This E and H are coming before O. Right? So it is ME and MH. Okay.
Yeah.
So the total word starting with ME. Okay, so that will be like say anyway starting with ME, these are all 1 into 1, this is fixed. So remaining is 4 factorial, right? With ME.
Yeah.
Okay. So similarly with MH, 1 into 1 into 4 factorial.
Yeah.
So this is also fixed now. Okay. Then total word starting with MO. Okay. So so you will have MOE. You will have, because you want to go to MO
Yeah.
mother, MOT you want to go. So MOE, MOH and MOR, because after this only MOT will come.
Yeah.
Right? So here it will be again 1 into 1 into 1 into 3 factorial. Right?
Yeah.
3 factorial. Then 1 into 1 into 1 into 3 factorial. Then 1 into 1 into 1 into 3 factorial. Okay. So yeah. So then MOR, then MOT. Okay. MOR. Okay. Then MOR. After this will come MOT. Okay. R, after R it is
Yeah.
T. Okay. So MOTE. After that will come MOTH. Okay. Okay. So MOTE. Okay. So MOTE is again 1 into 1 into 1 into 1 into 2 factorial.
Factorial.
Right. So this is answer is 2 factorial. Okay. So then comes the other word is MOTH. Okay. So here comes mother. Okay. MOTH, because the other two are ER. Okay. So because RE is not the one, ER.
Yeah.
So next it will come. So everything that has come before this you will add it together.
Yeah.
So the position of this word mother will be kind of 5 factorial plus 5 factorial, okay, plus 4 factorial plus 4 factorial plus 3 factorial plus 3 factorial plus 3 factorial plus 2 factorial. Okay, so this is, after this only your mother is going to come. Okay. So basically this is 120, 5 factorial, this is 120. Okay, then
20.
your 4 factorial is 24 and 24. So this is 24, this is 24. Then your 3 factorial is 6, 6, 6, 6. Then your 2 factorial is your
2.
2, 2. And then the position means you have to add the 1 also, because you want to add this also, right? This is 1. That if you add, then only you will get the position. So you are adding. So that is also important. So you are adding 1 here. Okay, so this is 1. Right?
Yeah.
So after adding everything, you will find the answer to be 3, 0. Okay.
Yeah.
So now you understand, like this is a bit complicated, but this is how it comes in JEE. Like things will not be that straightforward. Okay. So there is one more numerical we will do. Okay. On that is on permutation again. Okay. So take a picture of this. Okay. So now you understand this is little bit complicated, but if you understand complicated one, you can do simpler ones. Okay. So the question is like this: how many 5-digit telephone numbers can be constructed using digits 0 to 9? Okay. So how many 5-digit telephone number 5-digit telephone number can be constructed using digits 0 to 9, using digits 0 to 9 if each number starts with 6, 7, okay, and no digit appear more than once. Okay. The condition: each number starts with 6, 7, right? 6, 7, okay. 67, okay. Each number starts with 67 and no digit
Is
repeats. So it is kind of no repetition. Okay. No digit repeats. Okay. So what will be the answer? Okay. It will be kind of yeah. Okay. So you have digits 0 to 9. Okay. 0 to 9. So how many digits? 0 to 9 is 10 digits. Okay. So out of 10 digits, you are fixed with 2. Okay. First two are fixed. Okay. So out of 10 minus 2, so you are left with 2. Okay. So and your 5-digit telephone number you have to form.
Yeah.
Okay. So you are left with 2. You are left with 8, and your combination of
5 digits.
combination of 5 from 8. Right?
8 CR.
So it
8
will be
C5.
8 C5. 8 C5. So okay, so this is a number. This is not a selection. Okay, so it's not combination. It is permutation. Okay. Understood, no?
Yeah.
It's a permutation because it's when you are forming numbers. If you make the arrangement different,
It
then
will be
also it will be it will be a permutation. So it is 8p5. Okay. So the other two is like 6, 7. So 6, 7, 8, p5. That means 6 can be put in one way, 7 can be put in one way, and this can be put in 8 p5 way. Okay. So the total number of ways 5-digit number can be formed is 1 into 1 into 8p5.
P5.
So this is a very nice numerical. So the answer will be here 336. Okay, so this is a very nice numerical. So when you are forming number, be careful that this is permutation. But when you are selecting a cricket team, arrangement does not matter. That is a selection. That's why it is combination.
Yeah.
So this numerical, if you understand this, you can solve many
Yeah.
something like this. Okay.
Understood.
Okay, you take a picture of this. Okay, so now we have covered almost all different types of numerical related to permutation and combination. You can extrapolate these principles, these understanding to more numericals. Okay.